Hi everyone. This is an example of a deriving formulas style question beginning from individual masses and the molar mass. Here we go. A compound is 7.20 grams carbon, 1.20 grams hydrogen, and 9.60 grams oxygen. The molar mass is approximately 540 grams per mole. Determine the empirical and molecular formulas for this compound. This asked us to figure out the formulas, the empirical one, the reduced simplified version, and the molecular formula, the actual formula for the molecule that corresponds with the molar mass. We have individual masses provided to us and the molar mass. We're going to follow a series of steps to figure out these formulas. The first step is to add the masses together. 7.2 plus 1.20 plus 9.60. Add those masses together. The total mass here, 7.20 plus 1.20 plus 9.60. Maybe you want to do that in your head. You can take your time. We're not in a rush. 7.2 plus 1.2 plus 9.6. 18. That's the first step. Add the masses together. The second step is for each element, carbon, hydrogen, oxygen, for each element, turn the mass into a percent. But don't multiply by 100, leave that percent as a decimal. Carbon was 7.2 out of 18. What percent is that? But leave it as a decimal. For the carbon, it's 7.20 grams out of these 18.0 grams. We're not going to multiply by 100 because we want to leave it as a decimal. We have to do that for each element. For the hydrogen, it was 1.20 grams out of 18. And for the oxygen, 9.60 out of our total. At this point, your personal style might be that you want to work out what those decimals are. Don't do any rounding right now, but your style, you might want to know what that answer is. I would encourage you, however, to try not to do that. Our next step is to multiply by the molar mass. And this molar mass is right in the question. It even says the molar mass is approximately 540 grams per mole. We want to multiply by the molar mass and do that each time. Gets a little bit repetitive. Times 540 grams per mole times 540 grams per mole times 540 grams per mole. Again, you might want to know what the actual answer is at this point. Let's try not to. Our next step is to divide by the atomic mass. The atomic mass is the number that we're going to pull off of the periodic table for each element. Here it's divide by carbon, 12.01 grams per mole. For hydrogen, it's 1.01 grams per mole. For the oxygen, divide by 16. So it was total up the masses, add them all together, and then turn them, each element, into a percent, but leave it as a decimal. Don't multiply by 100. Here it was the carbon, 7.2, over the total, hydrogen 1.2 over the total, same for the oxygen. Then multiply by the molar mass, which is in the question. Then divide by the individual atomic masses from the periodic table. For example, 12.01 for carbon. We have this calculation to do, and what we need to do is round that off to the nearest whole number. So I'm doing my calculation. 7.2 over 18 times 540 divided by 12.01. I get 17.985. I need to round that off to the nearest whole number. 17.985 rounds off to 18. Do the same thing for the hydrogen. 1.2 over 18 times 540 divided by 1.01. This gives me 35.64. 35.6, that rounds up to 36. One more time, the oxygen. 9.6 divided by 18 times 540 divided by 16. Works out to, on the nose, without rounding at all, 18. 18. These answers, these whole numbers, are the subscript values for the molecular formula. So this means the molecular formula, look at what we have. Carbon, 18. Hydrogen, 36. Oxygen, 18. If we wanted to, we could calculate the proper molar mass here, and hopefully we could find that it's approximately 540. To determine the empirical formula, we're looking at these subscripts, 18 and 36. Can we simplify that down? What's the greatest common factor of 18 and 36? How can we divide these numbers to make them smaller? Well, the greatest common factor of 18 and 36 turns out that it is 18. I can divide all of these numbers by 18. Carbon 18 divided by 18 is 1. 36 divided by 18 is 2. And 18 divided by 18 is 1. So the empirical formula is CH2O. The empirical formula does not have a relationship with the molar mass. It does, however, have a whole number relationship with the molecular formula. When we have a question that gives us individual masses and the molar mass, and asks us to derive the formula, figure out the formulas, we have these few steps to follow. Add the masses together, find that total, take each individual element's contribution and divide by the total, like you were going to find the percent, but don't multiply by 100. Multiply by the molar mass each time that molar mass was in the question, then divide by the atomic mass. The periodic table has to say 12.01 for carbon, 1.01 for hydrogen, 16 for oxygen. Whatever your calculator says, round that off to the nearest whole number. And those values become the subscripts of the molecular formula. Sometimes a question will ask you to go a little bit further and find the empirical formula. Then you're looking at the subscripts, trying to simplify it down, trying to reduce them down, thinking about the greatest common factor. The empirical formula doesn't have a relationship with the molar mass. And I hope that helps.